Good morning everyone. So in this session we are going to discussing about this unguided transmission media. So in the previous session we are focusing about this guided media, and in this session we are focusing about this unguided transmission media. So what is meant by this unguided transmission media? So in the unguided transmission media, which means how the information is transmitted from one end to another, from source to destination, without requirement of this physical presence of cable. So assume that this is my transmitter is there. So I need to transmit information from the receiver, right? So previously we are using some kind of physical presence of cable is required between this source and receiver. But in this unguided media, I don't require this kind of physical path communication cable. Either maybe a coaxial cable or fiber optic cable or shielded twisted pair cables, etc. Any kind of cable. So here in this unguided media, I don't require any kind of physical presence of cable. Here the information is transmitted in the form of this a wave values only. Either should be in the electromagnetic wave values only. So how the electromagnetic wave is transmitted in the wireless communication, that information is transmitted from source to destination, transmitter to receiver, that we calling as a unguided transmission. So in this session we are going discussing about this unguided transmission media. Apparently we calling as a wireless communication media. So while coming to this unguided transmission medium, so in the unguided media, which means here the air acting as a medium through which the electromagnetic energy can flow from one end to another end. So in the guided media, there's some kind of cable, some kind of wires is acting as a medium between the source and receiver. But in the unguided transmission, here air acting as a medium, because the information is transmitted through in the form of this air values only. Assume that one I'm having as a two sections are there. One is transmit section, as well as we having as a another section is there. We calling as a receiver section is there. So here the information is transmitted in the form of this air communication. So here the air acting as a medium, because the transmitter is send the information into the air and receiver is taken the information from the air values only. So how the air acting as a medium here? Because electromagnetic energy is entering into the air, and this electromagnetic energy passing through the air and reaching the receiver values only, source to the destination values only. That is the reason in the wireless communication, the unguided transmission communication, the air acting as a medium, which means the electromagnetic energy is transmitted from one end to another end. And so in the first one, in the unguided media, first one, which is radio waves. What is meant by this radio waves? Radio waves also nothing but is a kind of frequency structure values only. Because in the unguided transmission medium, when you go for this wireless communication medium, so here all the kind of information in the form of this transmit through some kind of frequency values only. We having as a based upon the frequency only, we can able to produce in the electromagnetic waves. So that electromagnetic waves transmitted from one end to another end. So the which means the radio waves also is a part of the frequency structure values only. That radio waves is propagating, that radio waves is transmitted through the electromagnetic, they produce the electromagnetic waves that are transmitted in all the direction for free space. Assume that this is my transmitter is there. So I can able to given the some kind of power supply to this transmitter, right? So this source or this transmitter produces the electromagnetic energy into the all the direction values only. All the direction values only. So how it is transmitted all direction? Because this in the point, in the source direction point, we are keeping as a one kind of antenna structure. So that antenna can converting of this electrical current into electromagnetic energy. So that electromagnetic energy, which means the electro waves are producing from this all the direction values only. And these radio waves are omnidirectional, which means signals are propagating into all the direction values only. Right? Assume that one. So we can't able to restrict the signal values. When you go for this omnidirectional values, we can't able to restrict the signals in one direction. But in the another kind of structure, we can able to change the structure of antennas. We can able to restrict the signal direction as well, because all the directions were not required for that one. Assume that for FM communication, we use signals in all direction. Right. For example, when you go for the silent communication level, or else when you go for this missiles communication level, the signals are transmitted towards only one prescribed direction. That specific path is required, not in all direction. So all the times omnidirection is not required. Sometimes we require about this direction pattern also. So in the radio waves are specifically used for this omnidirection. What is omnidirection? The signals are propagating, the signals are transmitted in all the direction, that we calling as a radio waves. And what is the range of radio waves? Which is from 3 kHz to 1 MHz values only. 3 kHz to 1 MHz values only. The range of frequencies, which means, so because of these radio waves, we can able to using our FM communication and a long range of signal transmission communication purpose. Also, we are using this kind of structure like FM communications or walkie-talkie communications or simplex communications or a full duplex kind of communications. We are going to using this radio waves. When you see this image structure, so in the radio waves, we have two things are there. One is earth surface value as well as a ground surface value. In this earth surface value, we are placing as one kind of transmitter antenna, which is source antenna. We having as a receiver antenna is there. The information is transmitted between this source antenna and receiver antenna. But how the information is transmitted? Because these signals are entering into the ionosphere region values only. Because here the information is transmitted through the air media. So air in the sense we having as a n number of layers are there. We having as a stratosphere, troposphere as well as ionosphere is there. So based upon the requirement, the information is transmitted. The signals are entering into the air medium and reaching into the other direction, into the destination direction, source to the receiver direction. The information transmitted through air value. What is air here? Ionosphere also acting as a one kind of medium values only, one kind of a layer structure values only. And second one is microwaves. What is microwaves? Microwaves are generally, which is a range between 0.3 gigahertz to 1000 of gigahertz, 1000 gigahertz. That we calling as a microwave frequency range. Previously in the radio waves, we having as a frequency range of this 1 gigahertz range values only, maximum of this up to 1 gigahertz range. But in the microwave frequency, the frequency is starting from the range of frequencies starting at 0.3 gigahertz to 1000 of gigahertz values only. So that we calling as a microwave frequency range. So in the microwave frequency range, so here what is microwave frequency? But when the information is transmitted from long range communication, because if I'm using this amount of frequency value, because 1 gigahertz is apparently is equal to 10 to the power of 9 Hz values only. So if I'm using this much amount of frequency value, that frequency is a terrestrial microwave transmission, a long range kind of transmission that is focusing upon a radio signal from one ground based microwave transmission of antenna to another antenna. And generally we are using satellite communications or missiles communications or aircraft navigation purpose. We are using this kind of micro signal values only, microwave kind of propagation values only. So in the microwave also we have n number of propagations are there. We having as a ground wave propagation, we having as a space wave propagation, and we having as a surface wave propagation, or else we are calling as a sky wave propagation. We have n number of modes of propagation are there. While in the sense, when you see in the radio waves, the information is transmitted through the ionosphere region. Similarly, in the microwave also, the information is transmitted through the troposphere region value, stratosphere region value, as well as in the ionosphere region value. Because in the air molecules, n number of layers are there. We having as D layer, we having as E layer, we having as F1 and F2 layer. So n number of layers of presence in the air medium. So these microwaves are entering into all the layers and reaching into the receiver values only. So in the microwaves, there are two types of transmissions are there. One is a terrestrial microwave transmission and second one is satellite microwave transmission. So what is terrestrial microwave transmission? Here in the terrestrial microwave transmission, the signal, the frequency producing, what kind of microwave frequency we are producing under the terrestrial microwave transmission level, that signal, that microwave frequencies is mainly focused upon the what kind of radio signal we produced, and that should be comes to the a ground based level values only, ground level of propagation values only, ground layer of signal transmitted from one antenna to another antenna in the ground kind of structure values only. But in the satellite level, in the sense, that should be in the form of this earth station to orbital station, because we need to transmit information from our ground station level to, which means the earth station level to orbital station values only. So how the information is transmitted here, that we're calling as a satellite communication. So this satellite communication, the satellite accept the signal from earth station to satellite station, that in the a long range communication level. So here when transmit signal from the long range communication level, I need to amplify the signal. I need to boost up of my signal. That amplified signal is retransmitted to the another earth station values as well. That we calling as a satellite microwave station. Right. Apparently, in the types of transmission, there are two things are there. One is terrestrial, another one is satellite. What is terrestrial? That should be information transmission. That should be the ground level, but this should be in the form of this orbital levels. That we calling as a microwave transmission modes of propagation. How many modes of propagations are there? There are three things are there. One is ground station, space station, and sky propagation, or as surface wave propagation. Based upon the information requirement, that should be either in the ground wave propagation level or as in the orbital level or as in the sky wave propagation. We choose the requirement accordingly. And third one is we calling as a infrared rays. So what is infrared rays? Infrared rays, generally we are using the communication medium. Generally the information is transmitted. When you go for this a TV range communication, a short range of communications, we are using this the infrared transmission. Infrared transmission, which means apparently we are taken about this a wireless technology, which means used for the communication or the short ranges. The best example of this TV and TV remote. The short ranges kind of communication level, we are in this IR rays. We calling as a infrared signal values only. And what is the range of this infrared? The frequency range of infrared which is 300 gigahertz to 400 terahertz. Because even though short range communication, but we are going to use the frequency of this very high amount of frequency values there, because the frequency range is in the form of this gigahertz to terahertz level. 10 to the power of 9 to 10 to the power of 12 or 10 to the power of 15 range was there. That is a high range of communication is there. And generally this kind of short range communication such as data transfer between two cell phones or TV remote operations or any kind of computer, this can be happens over there. So when you go for the short range communication, we generally are in this infrared communication path values only, because the frequency structure is increases. The frequency structure is increases, the lambda values decreases. If the lambda apparently we calling as the size of antenna values decreases, so we can easily mount of this antenna in my TV remote structure, so that I can able to operate the short range communication. I can able to sync up with my TV and TV remote. The specific frequency you can able to sync up that one, then I can able to operate the TV as well. That we calling as the through infrared radiation values only, infrared wave values only. And the last one is a light wave communication. So what is light wave communication? The light wave communication, which means in the light rays, the electromagnetic radiation is propagated. When you go for this, the guided media, the last session we discussing about this guided media, there we discussing about this fiber optic cables. In the fiber optic cables, so in the there we are in the form of this a light rays, information in the form of this light rays. Similarly, in this also, the electromagnetic radiation is also using the form of this light rays. That is what kind of wavelength we are using that one, and that should be very high amount of range values only. So in this wavelength, in the frequency range values which is 430 to 750 terahertz values only, and this is we calling as a unguided optical signal such as laser values only. So we having as a laser signal values only, that we calling as a one-way direction values only, a single direction values only. When you go for this radio waves, they are discussing about this all the direction, discussing about this omnidirectional. The signal is transmitted towards the all the direction values only. But in this light wave transmission, we are developing at the laser principal values only. That should be in the form of this unidirectional, in the form of this a single direction. When you see this one, here I can able to transmit the signal from one end to another end. So I am producing the light rays here, and this light rays is transmitted to the destination place values only. So this we calling as a laser beam values only, a laser beam, a detector values only. One is generator values, another one is detector values only. And so while coming to this summary of this session, so in this session we are focusing about this a unguided transmission values only. What is unguided transmission? Apparently we calling as a wireless communication transmission values only. In this wireless communication transmission, we are discussing about this radio waves, and we discussing about this infrared waves, we discussing about this microwave waves, and a light rate waves, the form of this laser beam values only. So this we calling as a wireless communication medium, or as a unguided transmission medium. In the next session, we are going discussing about is a telephone network values only. So in the telephone network, how many types of telephone networks are there, which is a public switched telephone network, which means a landline communication or else a mobile phone communication. How many types of the networks are there? So that we discuss in the next session. Thank you.